So let's start, guys. So in this particular video we are going to make a simple neural network. It's a simple fully connected neural network we are going to build using the PyTorch library. So this is the more agendas of the tutorial. What are the different packages we need to build this network, to load the data sets and to process the data sets, what kind of package and how to process the data sets. Mainly in this particular video we will use the simple dataset, MNIST dataset, to build the fully connected neural networks. Then after process the data, after convert the data in that particular format that we have to use to train the model, then we will use the simple fully connected neural network. Mainly I am going to use the PyTorch library because it's very easy and implementations. Then after building the network, how we'll train the model using the data sets, then we will check the training and test data accuracies. So let's get started. So first we are going to import the different packages here. So first, that the package that we create, the torch. First we have to import the torch library. Then from the torch library we also need to import the neural NN, means the neural network, all the modules, all the neural network links. If it's a linear neural network, what are the batch sizes, loss functions, all the things are already inbuilt in that particular module. I'm taking as a NN. Then we will import the optimizations algorithm. Like if we want to use that the SGD, stochastic gradient descent, add-arm, etc. So for that reasons we will use this module, optim. Then also we have used another modules, like it's also inbuilt in that the NN modules of the torch NN modules. So it's a functional. Okay, all the functions that we required here, means the ReLU, all the different kind of functions are already in here. Dot function. I am taking as F. So let's run it. I think first we have to install the torch. So it will be better if we use that, change the runtime here. It's already runtime is chosen GPUs. It's always better if you always use that GPU. And also how to load all the tensors in the GPU, and also if you use that CPU, and also how we'll use the utilizations power of that CPU, and if you use the GPU, how we will convert that convert the tensors into the GPU. Then I will see all the things. It's already installed. Okay, then also we have to use some packages to transform our data, to transform in the particular format, like in different kind of batch sizes that we will use to train the model, like that kind of things. So here we will use that this library utils from the torch. It's already available. Utils, from here we will use the data. And because I am using this data, because if you search on the torch PyTorch websites, there have lots of lots of data are there already. We don't need to download from anywhere. So if you wish to download, then you can, but I think for the practice purposes it's don't required already. Because for this tutorial I am just use that data sets. First, mostly I have used the simple dataset, like it's a MNIST dataset. You know that MNIST dataset is like a handwritten digits datasets. So we have used the datasets, and how we will convert the dataset in a particular format. and then using the data loader we will convert the in form of some different kind of batch sizes and different kind of hyperparameter tunes also we have used to train the neural network, and also increase the accuracy of that. So let's see step by step. Then we have input here the data loader. Okay, then also from that this library will helps us to convert the data in the particular formats. Then also we require the data sets import, and this data sets already a torch vision. Torch vision data sets, you can search in Google, there are lots of data are already there. Data set, okay, as data set. Then another thing also we require the transform, we have to transform the data set. Torch vision, let's take it as same name. Okay, primarily we require this one, if we need it then we can add here. So invalids import, what happened? Okay, got it. It's mistake, it's I have made that spelling mistake. Let's run again, not an issue. Again it's a invalid syntax. Yes, it's torch, then utils, there we have the data library, then we have to from here. Okay, that's my, I have used that import 2 times from. Okay, now we have to load the data first, load the data, and we have to also convert the data in the particular formats. So from to load the data, so first of all uh, we have two data sets, mainly trained data sets as well as the test data sets. So first let's define the batch sizes. So first let's define the trained data. First let's train data sets first. So from the data sets I have used this module to use the data, MNIST data. So data sets, and we have used MNIST. MNIST, okay, I think yes, MNIST data sets we required here. So first we have to path, in which path we have to save that. So here you can see our root directory, we have to define that in where we have two data sets. Let's define that our data, it's our data, here it will be. Then we have to use train data, yes, true. Then we have to transform the data, because if we don't use it, so let's first, now I am not going to transform the data. First let's download, then I am going to transform it. First let's download it. Let's first download it. Okay, you can see here one data folder will be created, and here you can see MNIST train data will be, it's a raw data. So it's a different format, different type of formats. So its label, its images, its label, it's open one thing, how it's look like. I think it start downloading, no needed. So it's a, I think it's the tar file, it's a compressed file are there. We have first, it will always better if we just take it, download it, and in transform format, transform. So convert it into the tensor, because it's, I mean, it's a image data sets, we convert, it's always better if we convert that things into the tensor format. Okay, it's transforms. Okay, now let's check how it's look like. Okay, same thing. Now if we just print the train data sets, then you will see. So here you can see it's a number of data sets is 60,000, data location seats, it's split trends, standard transform. So let's its first element, how it's look like. So you can see it's look like this type. So if you want to print it safe, then also you can, sorry, what happened, tuple objects have no attribute shape. Okay, it's a tuple object. So okay, it's first of all you can see it's the tuple objects, and its corresponding vector representations is the first one. So if you see that, it's actually, this is the actual original data set. Okay, and the second object is what is its actual level of that particular data sets, it's a 5. So if we want to print it safe, now you can see, so it's a vector of size 28 by 28, means it's image, square image, it's a square vector. So now we have to reshape it into the form of 28 into 28, means if we see 28 into 28, it will be the 784, its dimension will be 784. Now we have to convert. So this is the another thing. So first let's download all the data first, then we will use the techniques. So here now we have to same things, but we require here the test dataset, test datasets, and now train. Now instead of train here, I will use the test. So it will better just make it false. Sorry, here we have to make it false. So this is our train data, this is our test data. So here you will see how much train data, test data. So train data is contents 60,000 and test data will contains the 10,000 data sets. So this is the train and this is the test data size that you will see. Now we have to convert these data sets in that particular format, means in the form of a batch sizes. So here we have to define the batch sizes first. So batch size here I have defined here that it will always better. Let's take it here 60. So they have the same standards rule how many web sizes. So just it's a theoretical, but you can use. So now let's for that for the beginning it's always better train. Now we have to train a loader, we have to convert in the form of a batch size. This now to convert into the batch size we will use this module, data loader. On this data loader, we will datasets. What will be our datasets? First, we have to datasets. Our will be the train datasets. This train data. Now, second thing, uh, what are the batch sizes? You can see also. First, that data set we have to put, then batch sizes, then shuffle. Also, you want to make the shuffle. All the things are there. Then you can explore it using in your sense. So let's first primarily start the things. Now here the batch size will be our batch size. Now next thing, that shuffling. SU sorry, SHU. What happened? SHU FFL. Shuffle equals to true. That's okay. This is our train loader, data loader. Now let's doing the same thing for the test data loader. Test data loader, instead of train we have used here the test. Okay, let's run it. Now let's see how it's look like, the train loader. So you can see here it's a object of the data loader object. So if we just the first element, sorry, it's a data loader object. So see its length. Yes, its length you can see here 1000s, because in a single loader we have 60 badges, edge badges, and total train data set is how much? 60,000. So here because of that reasons it's 10,000. So if I make it here the 65, then how it's look like? What is its size will be? Yes, 924, because 922 is why? Because that I have used the batch size is 65 and the train data size is 60,000. So 60,000 divided by, if I make 65, then you will see. Yes, 923 something, so 924, because 923 it contains only the 65 type data sets and the rest of the data set will be the 924 batches. Okay, I think you will understand the things now. I want to just see that how these first elements look like. Okay, data loader object. Just a minute. Let's see. Just I want to see the its first object dot batch size batch sampler. We want to its first element. So here, if we want to see the first elements of this data loader, so instead of the zeroth element, because it's a iterated element, so I have used that iterated functions. TER. So okay, now we have to call the next. Yes, you can see. So here the in this particular element, how much elements are there? Total. It's a first batch. In this particular first batch is what is its length. You then also. So it's better if we just take the length. two element, and because of that, first element is that the vectors of edge images, vector representations of images, and the second element is that the targeted, means what is the actual output of the image. So because of this reason, so this size 2, if we just make it 0, then you will see it's 65, because our batch sizes is 65. For that reason it's 65. It's a single batch that I have to use. Similarly for the test data set is also, I think you will understand. So the data loader modules helps us to make it as the proper format, that now is these data sets we will use to train our neural network. I think you will understood the things, how it's work. Okay, now the next step is we have to build the simple full neural network, connected neural network. Now this is our job. So to build the model, so first we have to make a class function. Class, let's call it as a neural network NN. In general we will use the things. So here it's a we have inherited the class from our the main NN modules. So we have is the parent module. Now it's the NN is the child module of that one. So here we have to use first the init functions. Self. Now here how much input size we have to give our, because you will see here in that particular data set is how much size will be 28 by 28, means that 28 into 28 how much, 28 into 28, if we just reshape the things, then it will be 784. So this will be our input size. Then how much number of classes are there, because it's MNI's dataset handwritten, it's a 0 to 9 means 10. So the number of samples, classes, number of classes. So these are our input of this module. Now we have to inherit that init functions from its parent module. So we have used that the super one, then nn dot nn and the self dot init from its parent. From its parent one. This is that. Now extra things we have to make the we have to define that the neural network first. So this is all the primary things we have inherited from its parent modules. Now we have to develop that. First let's define the neural network, fully connected neural network. So self fully connected layer 1, first layer, on that one linear, I have used that simple neural network I have building here. And let's check using the simple neural network, let's check how much accuracy we can achieve. So simple linear network we have to build. And here first input, it's what, input size, its input size, its input size. And now let's say its hidden size I have chosen here, let's take 60 hidden size. I think it's better if we use that 60. Okay, batch size I have choosing 65. Yeah, hidden layer I have choosing 60, not a problem. Now in the next one layer also I have to add here, it's the second fully connected layer. Here input size, instead of input here it will be 60, and output size will be what, output size will be our the number of classes. Number of classes. Now next things we have to join forward, make the forward, define the forward methods to join these two neural networks. So define that forward self, and also this x will be our vector. Here it's the input size, but here it's actually the original vector that we have to use here. Now here output will be what? Output will be our the functions that we have used here, the functions, ReLU functions we have to use. First let's call that ReLU. Then we will use this connected first neural network. On top of it we will use the ReLU functions, and then here we have used the x, and the x here, the x that I have used that for the forward functions, it must be a 784 dimensional vector. Okay, and on top of it the output we will got the 60 dimensional vector. On top of it we will use the ReLU functions, and top of it now next x will be our what? In next x I am using here that I am not using here any function. We can use here the sigmoid functions or softmax layer, we can use it, but suppose I am not using anything, so here only I have used that the self dot fully connected neural network 2, and on top of it we have used that x. Now we will return that x. This is simple two-layer neural networks. Hidden size is 60. So here we can use the sigmoid functions, but not I am not using, but make it more simple. But you can use it. Now let's check the parameter. Now let's define the parameters that we require. So let's run it. Okay, now let's define the parameters what we require. So first let's define the devices, because we are using the GPUs here. We also want to utilize the GPU power. So here our device that defines torch dot device. So it will be must be CUDA if torch dot CUDA is available. Else we will use here the CPU. Okay, so let's run it. I think some syntax I have make some torch. It will be CUDA if torch CUDA is available. Okay, is available. It's a single sentence. Now if we just print that device, then yes, it's, you can see it's a CUDA device, because already it's a GPU. Type is CUDA. Okay, so now next we have to define our parameters. Here input size one parameter, next parameter is number of classes, next parameters, and learning rate, it's another parameter that we have to use. Now how many epochs? Also epochs, suppose let's I am going to use here the 5 epochs, let's for basic, and learning rate I am going to use 0.000. Let's make it simple, 10. Number of classes and number of input sizes is what? 784. Okay, these are the parameters. Okay, now let's using this parameter, now our we have to define that new, first we have to build the model using this parameter, then we have to loss functions and also the backward techniques. It's very simple. So first let's define the model. Our model will be what? This class that we have defined, this is our model. And now here input size, first we require here the input size and number of classes. Let's copy paste it. Input size will be our input size, number of classes is your number of classes. Okay, number of classes. That's the sample model we have. Now we have to convert this model into our GPUs. Otherwise, in default, it will use to our CPU power, but we have to convert it into the GPU because we are using GPU. Before that, we also want to utilize that power, GPUs. And now we have to use that the loss functions here. Mainly, I am the simple loss, cross entropy loss. I am going to use, so it's very simple. Criteria. Okay, here from the NN modules, cross input, I think cross entropy loss. Yes, cross entropy loss we have to use here. Now optimizer also, for these optimizers helps us to update the weight for our back propagations. So here optimizers we have to define it. Optimizer. So optimizers we have used these functions in the optim. It's available. Adam, it's always better because more sensitive one is the Adam. It's most usable and most optimizer functions. Model. Here how much model parameters. It's defined in the next cell. First let's check how much parameters we have. Let's load the model first. Okay, now let's see the model parameters. Model. Yes, you can see here the model parameters. It's a object. Yes, you can see the model parameters. It's a two parameters are there. It's a first one is that fully connected neural network linear layer, and here its input is 784, output feature is 60, bias true. Similarly for the same, this is that our parameters. So now use these parameters here. For these optimizers we will use these model parameters as a function. Okay, now also we have used the learning rate will be our LR. I think I defined it as LR. This is our criterion and the optimizer it's defined. Okay, now let's train the model. So before training the model, one thing we have to define, we have to because if you see the data sets, because I am seeing the data sets is currently not 784 dimension, we have to reshape that data sets in the form of 784 dimension, then we will pass it, and also make some loops to before training the model. So it's the part of the training the model, so let's define here. So here for epochs in how much epochs we want to run here, that I am taking here the 5 epochs. For age epoch EP I am defined in range of the length of the epoch. Epoch spelling is okay, EPCOCH. Range the length of the epoch. Now first we have to see what the epoch number, then epoch number EP. Now next we have to use the batch sizes, and for batch index we needed index IDX, and there and here first, because we have seen that using the next and iteration, the first one is that the number of inputs, then the second one is the target value. Okay, here the first one is your data, original data we have used to train the model. Now next one is the target. Okay, that will be in our the train data loaders. And because I am going to extract the index as well, we have used the enumerate function. Enumerate functions, then train loader. Okay, now next thing is that we have to move the data that we have using for edge iterations in the GPU. Data will be our data, otherwise it's always give the error, because our model we have used model in our GPU, but if we use the data in that CPU, it's always show me the error. So we have to convert into that GPU. Device always will be what I am device, I think. Yes, this is our device. Now data is moved to the GPU. Now similarly for the target values also you have to move to the GPU. Target values also move to the GPU. It's okay. Now next thing, so we have to convert the data in the form of a. Let's run it first. Okay, let's run it. How it's look like. Okay, range for EP in range, length of the epoch, not length. Why I am using here the length? Because it's already integer, so it's 0. Enumerate, I think I have make some spelling mistake here. Enumerate, M-E-R-A-T-E. Yes, now you can see. Yes, it's taken the data. Means it's iterate for all the datas. We don't record. Let's stop it. So now if you see the what it's the data look like. Yes, its data look like a batch sizes and its device is Kura, means it's a single GPUs are there. So if you see the length of this data, then it must be 65. Yes, it must be 65. And similarly the target is values also length will be the 65. Yeah, now the thing is I have data, first data, let's say in the batch of the 65, it's the first. So if we see it save, yes, it's one, means it's a black and white image, gray image. For that reason it's a one channels are there, and 28 by 28, but we need to convert the 20 by 28 in the form of a 1784. So how we'll do that? We have to reshape it. We have to reshape it. Data 0 dot reshape, and we have to reshape that. First one will be this one, this will be as always constant, and -1 means now first dimension will be always its great scale image, and this one will be our reshaped. Now if we make it, now you can see, now if you just see its shape, then you will see. Yes, now you can see its shape will changed into 784. Okay, this is the simple technique I have to use here. This is for the single vector, but I am going to use in the whole data. Yes, now this will be our new data, will be data Now we have to reshape it. Now we are going to now we have to use our model to predict the score. So what will be the score? Scores will be, we have to use our models to predict the scores. Now we have to pass the data to that particular model. Now our shapes in particular format, this one. Now I think it will taken. Then we have to use the loss functions, calculate the losses, and losses the criteria using these loss functions criteria. Now what will be our actual predicted values and what will be our targeted values. Based on that we have compute the losses. Now after computed the losses, we will using that optimizer, we will call the optimizer to update the weight. So first of all, to update the weight, first of all we have to initialize that all the zero gradients. Grad will be always zeros. First we have to initialize it. Otherwise when in the next loop it will from the previous the gradient it's automatically considered. So for that, to update the weight, it's always a better practice to initialize that gradient into the zeros values. Now next we have to use that back propagations. It's very simple in PyTorch. Just you have to use that this method, backward. Loss functions. Now on the loss functions we have to use that backward functions. Okay, that's now in the next step we have to optimize your step. We have to use this step, means that it's a gradient descent or Adam, because that the optimizer function I have used the Adam function. It's a Adam, its steps will be showing here. Okay, this is that simple network. Before going to train, let's run it. Scores is equals to model data. I think linear argument input positions on must be a tensor, not okay, because what is the main reasons you will see, because the data that save of this data is 1 into 784, but we have to convert it in the form of a 784 dimensions. So for that reasons it will say throw me the error. So instead of day 1 data dot steps and first values, same error. Okay, let's check it how it's look like. Okay, it's my bad. Why I am using these save functions? Can use 1 or 0, anything. Cannot be multiplied. Why these things? Data dot reshape model, when I going to pass the model 784 dimensions, I think some mistakes are there. Let's check. If I see the data resets, yes, it's the value is equals to data tensor value. Now let's check its length. It's 1 0 first value, total it flattening all the things. For that reasons but we don't want this thing, because you can see here it's all total flat the things. If you see its length, this much, first one, second, not here, let's check zeros, this, this, zero tensors. I think that's the mistake, that the match dimensions is not matched here. I have taken the dimension is 784, but it's shown here that the dimensions, that after reshaping the dimensions it's this much. So there are some mistakes. Let's find out this mistake first. Okay, the mistake is here I am using the constant number instead of constant 1, because I am using the 1. So for that reason it's always taking 1. So it will always better practice here if I use this shape first dimension as shape 0 1. Now if we just see this thing here, then how much it's look like. Yes, now if you see its length, 1, okay, it's how many lengths of the first elements is 64. Okay, now let's take it here and put here. Okay, now let's run here. Let's see. Oh, let's see, let's wait some times. I think it's start working. So also you can here see the RAM management. So this is the system RAM, 12 GB, GPU RAM. Epoch 3 is done. Okay. Now next thing is our backward operations, all the things. So now check the accuracy, to how much accuracy we can achieve here. So similarly we have to make a functions accuracy check, ACC, check accuracy. So here we have two things. One is the loader, means it's a train data loader, and the test simple I am calling here the loader functions, and the model I have to pass through here. So we have to find the number of correct. Let's consider 0 first, number of wrong. Let's consider 0. Now we have to fix the model in that evolution mode. Eval mode, we have to fix it. Next we have to fix that we have to make that there have no gradient. We have to make the computations without any gradient. So we have to fix our systems it's with no gradient. Torch no gradient. Okay, now for x will be our data, y will be our target value in a loader, means it may be a train loader or test loader. So our first x, we have to convert that x in the in a device. X means in GPU, because models in already in our GPU. To device, Similarly, we have to convert y to our device. Now same process. Now we have to compute, we have to reshape the first, we have to reshape that our yeah, the same process, the training, that the things we have defined. Instead of data, we have used here the x value. X value. Now we have to compute the scores. Sorry, it will be capital, not capital small. Now we have to compute the scores. Scores we have to convert, put the model already in our GPUs. Put that x value. This is score. Now we have to compute the losses. Not losses. So first we have to means predictions, we have to consider the predictions. So here the scores, in the scores value first, let's see, let's comment it out first. Okay, x data, now we have to pass the data to our model is already trained. Yes, now you can see this is the predictions for its 10 classes. This is the first batch prediction, second batch predictions, third batch predictions, and suppose if I want to make the predictions, so first this is the predictions values gradient function. Now let's check that what will be the a. Got it. This is our score. If I just make this is our score actually. Okay, this is our score, means that I have seen. Now on the scores we have to so let's see. Let's first see the things. Score. This is the score. This is the first element of the score. What would be the output? It's the output, the maximum value. What will be the maximum one? We have to take the maximum one from here, and the in the on which axis we have to row wise. Axis max. Okay, maximum. This one means here these tensors. So first let's print side by side. Yeah, so here the maximum is one, this one is maximum, this one is the maximum one, this maximum value, this one. So here what is the index of the maximum? This is the we want to know. This is the actual index will be, first will be the value, suppose a, I am storing b. So if we just store it, score zeros dot max, what happened? Okay, so here instead of first element I have considered here all the elements. Okay, not I am going to use that row wise. Axis is equals to, okay, now you can see this is that one, this is the first maximum value. What is its index? 5. Now this is the second maximum. What is in this? 3. Similarly for here, this is that. So here 5 tensors are there, because if you see in that 65 last total rest 5, so total we have 60. 10 data we have, total how much data are there? Total 60,000 data. 60,000 divided by how many badges we have made here? The 65 age batch sizes. So if we divide it 65 923, I think batch sizes I have defined here. How many batch sizes? Yeah, 65 923 point something, means total 924 badges are there. So if we just make the multiplication 65 into 923, then these much, and total we have 60,000. So last batch contains only 5. Okay, because of that reasons. And this course, this core actually is coming from here. So because I am not using the functions here currently, so for that reasons it's that one. And this is the indexes. And now we have used these indexes to find the originals values. What will be the is originals values? So if I put here a comma b, b will be our index. B will be our index. Okay, this is our index. Now we have to use this index from the from our original target values. What are the actual targets? If you see the targets one, okay, this is the index. Now if we just see the target ones, total this target 5 3 8 7, and all the prints, actually its predictions is always all correct. This is the targets and this is that. So if we use these predictions, means here our predictions is y in this tensors b equals to target. Yes, true. Now let's take its sum. Yes, you can see here total 5 out of 5 is true. Okay, so for that reasons, nothing else. Now instead of, because only we have used here the train data, so because of this all the things are correct, but if we use the test data loader, then you will see, but this only this way we have used this score. Okay, now this is our score. The same things we want to apply here. So here scores, and this a1 is the maximum, is the axis. So axis, if you see these functions, max functions, on that max functions, the axis 0 means that it's a row wise, column wise dimension, means is that how, in which dimension you want to make the dimension. So just google it, then you can understand. So let's define the function first. Let's complete it first. I think it's a very long video, but I think it helps us. We don't need to require the values, how many scores are there. Only we require that in what is the indexes of that one. So here we have used the prediction. These are the predictions here, and these predictions will be from scores.max1. scores.max1. Okay, now we have to compute the number of corrects. Number of corrects will be equals to plus equal. Number of corrects will be predictions in this value. Equals to prediction equals to what value? Original value is what? Original values is y. and this is that sum. And similarly, number of samples. Okay, it's not number or wrong, sample total. How many samples total we are going to put? Number of samples, total predictions. And it's a simple 0. In dimensions will be, means in first dimension, in 0 dimensions we're going to make the sums because of that reasons. So this is our predictions. B, if we just see, means how many samples are there, B dot sum 24. C means number of samples. Here prediction scores means here this much predictions are there. Total sums, not sum, it size, I think. How many samples? Sorry, it's my bad. It's a size. You can see, yeah, total 5 samples are there for that. But if you make 1 here, then you can see also, yeah, it's through the error because we have to make the dimension 0 dimension 5 for that reasons. Okay, this is that simple technique. Now we have to print the things. First we have to print that got number of samples, number of samples, number of samples. Okay, first correctly total sample, it will better, total number of samples equals to this, and correct value prediction, it will be prediction predictions with accuracy. Our accuracy will be what? Accuracy will be number of correct values. It's a tensor one, we have to convert into the float first. Yes, number of, because it's a tensor one, you can see it's all are the tensors. First we have to convert into the float values, then total number of samples. Similarly, float samples. Okay, now we have to make it now we have to make it in percentage into 100. Okay, that's okay. Let's delete that cell to make more clear. I think after that we have to set our model to that train mode. to set the model to our train model. First it will be model, we will loop the model. It's not required, but it's always a better practice to set the model into the train mode. So first that function is load, that first we will give the loader function, then to check the accuracy, then from here we will see for each batch and how much accuracy we can achieve for the train data as well as for the test data. So check accuracy, we have to call that. Now on this one, first let's the train accuracy, how much accuracy we can achieve from our train loader. Train loader, we have to call that model because we have saved the models in the save model. Loader is not defined. What? Train loader is not defined? Let's see what happened. Think LOA. Okay. It's my mistake. Yes. 92. All are the same predictions. What happened? Yeah, you can see the predictions. Yeah, this is the predictions. This is the accuracy. Okay, now you will see the number of 7, number of corrections, number of samples. This is that train accuracy for each data sets. Now if you see the test accuracy, I think it's my mistake. I have that we have to trim these functions on the outer loop. Yes, so total number of samples you can check 60,000. Number of correct sam. Okay. It's my bad here. Sorry for my number of correct predictions here. Correct predictions equals to number of correct equals to, yes. Now you can see the training accuracy. Yes, 92.113. This is our the training accuracy. And let's check what are the test accuracy. Yes, 92.2%. Okay, you can also improve that one if you use that dropout, if we use that the learning rate, if you let's check learning rate, this one, and I have also make that epoch up to 7. Let's take it 7. Okay, now train it again. You can skip this part if you don't want. Now let's check how much accuracy we can achieve. If you want, you can skip that or forward. Yes, our training phase has done the same thing. Now let's check the accuracy. It decreased 15. What happened? So you can see just we have decreased this. So learning rate, how much crucial is that learning rate? I am just decrease this learning rate. So first 15% accuracy again. Just increase the learning rate. So let's decrease it more little bit. More little bit decrease. Now I am going to take it simple 4. 3 is okay. 3 is okay. Okay. Now let's train again. Okay, now let's check the accuracy. What happened? I think something wrongs are there. What happened? Data loader, data to device. Okay, let's load the data loader first. Load it again. Load these things. Okay, let's define the model. Optimizer. Train the neural network again. I think because of the weights that I have used the 0 grads here, but I don't know why it's not updating. It's taken that previous one. I think something data overrides are there, making the data overrides. So for that reason, it's now let's check. I think it here we can achieve 21 number of correct predictions. So I think something's wrongs are there. Let's find out first why these things are actually happening. Okay friends, I got the point because that I have update all the things, epochs, learning rates. Here I am not using the dropout, so update all the things, but I am not update the optimizer function. So for that reasons, I will drastically sorry for that mistakes. So here just I have taken that epoch size. Suppose let's take one and the same learning rate. Okay, now let's update the model. initialize the model, update the optimizer, then let's train it. Only single epoch I have trained the model. Now let's check the accuracy. Now you can see the, let's check the accuracy. For a single epoch, 93%. Okay, and test accuracy is what? Yes, 93. Now let's improve that performance. Let's decrease the learning rate and increase the epoch. Suppose 3. Update the model, update the optimizer. Let's train the model again. Now I have used the 3 epochs and learning rate decreased. Okay, now let's check. '93 to how much we can improve. So it's decreased 90%. Okay, no problem. Now let's increase little bit. Let's increase up to 3. Let's see what happened. So you have to test using the hyperparameter, but increase I will show using AutoML technique how can we will find out the best hyperparameters for choose the models. We will see the things. Now let's first try to understand the simple neural network architecture, how it's work first. Okay, now let's check the accuracy. Yes, you can see only increasing the epoch size up to 3. So its accuracy we can achieve up to 96%. And what are the test accuracy? So 95%. So only increase that accuracy. Also you can just play yourselves. You can here use the sigmoidal functions. You can use the dropout in the next video. In the main thing in the next video I will use that RNN and then LSTM. Next how we'll build that, then transformer model, how to add the attention, then how to make a neural translation model. All the things I will it will come. So I think from this video, I think it's a very long video, but I think from these explanations you will understand how it's internally it's work, how the data sets load the data sets, how we'll make the batch sizes, how it's look like, how to construct the simple. It's a two layer neural fit for neural. So it will be better if you just play things. Suppose I am here 30. Now I am using here 60. Now one layer I am just want to add here, fully connected 3 here, instead of 60 here 10. Okay, now here one ReLU layer we have to add also here. Okay, three. It's okay. So it's okay. Now just I'm adding one extra layer here. Now instead of 3 I'm just making the epoch same 1. Now let's check how much accuracy we can achieve. Let's load the model first. Let's upload the optimizer. Now let's train it. I think one layer we have added. I think it's take little bit more time. It's now let's check the accuracy. Previously it has 93%. Now after adding one layer, let's check how much accuracy we can achieve. Yes, 90, it's decreased. Okay, no problem. Let's take the hidden layer size. So you can play with yourselves. Okay, these are the techniques. How much layer? It's one technique, and also it's a very easy one. If you just instead of just if you use the pipeline. In the next video I will show you how to the simple neural network build using the pipeline techniques. It's very easy. It's a single line of code, then you can easily build a neural network. It's very easy, but the motto of this first video is that to understand the things, so how the internal things are internally doing the things, and how these things are internally connected, how we'll play with the things. So if you like the video, please share with your friends, and just comment below. Okay, thanks guys.